Good. How'd you guys do on the prep?
I think I did okay.
Yeah, it wasn't too bad.
Yeah, it was okay. I guess we're all gonna have kind of different like answers on that first part of part 2 or most of part 2. For 7.
Yeah, because that's, yeah. So for number 7, wasn't it just like once you get 5 random ones, you just add those all together and divide by 5, right? To get the
Mean? Yeah. I gotta get my calculator. I'll be right back. I'm just out in the hall. Okay. Yeah, and then the graph there is like we're all gonna have a different answer for it.
Well, do we want to start going through stuff? I don't know.
Yeah, so
Okay.
I'm just making sure I got the right answer that I have.
Yeah.
Okay, for number 5, it's got like an error, but for number 7 in part 2, there's an error. Like mine was supposed to be 5, but like it because it says I think it's supposed to be 34,400, but I just wanted to make sure that that was what I was doing. Anyway, never mind. Okay, should we start?
Yeah. Do we just want to go over ones that, I don't know. I guess we can just quickly go over like the 6 ones. The first 6.
The first ones, yeah.
Yeah. So, what is sampling distribution? Just the set of all possible values.
I can't hear you.
Let's see. It's the set of all possible values that could occur.
Yeah,
I think.
all the sample means. Okay. Number 2, what's the shape of the sampling distribution of the sample mean when the data are normally distributed? This follows one of those laws or rules, and so it would be normal.
Yep. Number 3, what is the shape of the distribution of sample means when the data are not normally distributed but the sample size is large? I said it's about normal.
Yeah, it's close.
Yeah.
I think this also follows one of those like laws or rules. Right.
It's a large size sample. Oh yeah, sample size. Large. Is that the limit theorem?
I can't remember which one it was, but yeah.
The law of, or maybe it was the law of large numbers.
I'm trying to remember which one it is. I'm trying to find it. I know it's one of them.
Oh wait, I have it written down on the back. Central limit theorem.
I think the law of large numbers is like that it becomes normal, like it, or I can't remember.
The law of large numbers, when the sample size increases, the standard deviation of the sample mean will get smaller.
Maybe that's not what I was thinking. Never mind.
And then the theorem one is if sample size is large, the sample mean will be approximately normally distributed.
Oh, it's number 6. That's what I was thinking. Because number 6 is talking about when is x normally distributed, and in 6 it says the x bar is normally distributed if the data were drawn from a normal population or if it was sufficiently large. That makes sense. Anyway. Okay, cool.
All right.
Are you guys okay with those first ones?
Yeah, I'm pretty good with them.
There's a new Hangout.
What?
I don't
know. He said he didn't get an invite, but I thought I sent him one, but I just sent to him. Maybe the first
There's
one.
I got a video call from Aaron. Did you guys get that?
I didn't get that, but I just sent him an invite to this one right now. Again.
Because I just heard that the thing went on.
Hey.
Hey, what's up?
Sorry, I thought I sent one to you, but maybe I typed your email in wrong.
That's okay. Don't
Sorry.
Where you guys at?
We're just going over the first few questions.
Okay, cool.
And talking about the central limit theorem and the law of large numbers.
So did we get through 6, 1 through 6?
Questions, Aaron, on any of the things?
No.
No.
Things.
Okay.
So should we go to 7?
Okay. Here's one thing which will probably be on the is standard deviation. And that was just thing, the mean, or wait, no. That's the standard deviation, then divided by the square root of n.
Yep.
Okay. Do you guys want to start the group quiz? I don't know.
Did you guys have to talk about part 2?
No.
Okay.
Do we need to talk about anything else in the prep? No?
All right. Cool. Is okay. Okay. Question number 3. If the population is right skewed and the sample size is 5, what will the of means be? I say skewed right because it's a really low sample size and the population is already skewed.
If it's already skewed right and it's low, yeah.
Yeah. Question number 4, same thing, population is skewed right, but the only thing is that the sample size is just as like a lot bigger. It's 100 instead of 5.
So would that be normal?
Shape of the distribution.
Could be normal. Yeah,
You think it'd be normal?
that's my best guess.
Yeah, because it makes it closer to normal.
It like counters the skewy. I don't know what the
Yeah.
word for that is.
Sounds.
Okay, when you're taking a sample size of 5 and it's normally distributed,
Normal. It's gonna be normal.
Normal, because it would just.
it would stay the same.
Question 6. The sample size is bigger and the population is normal, so it's gonna be normal.
Mm-hmm.
It would just be normal. Wow,
Seems-
we have a bunch of normal answers. I don't know. That's odd. When would the distribution of means be normally distributed?
Oh, would
Anything where
it
the
be
population is normal.
the population normally distributed,
Small and
right?
the sample size is large. Is it large and small?
Yeah.
I think it would be.
Yeah.
Large and small.
The first 2 and the last one.
Yeah, skewed right and the sample size is large. That makes sense. So
The first
one,
and
two,
last.
the last one,
Mm-hmm.
not that third one.
Okay.
Which one gives the best explanation in the central unit theorem? Last one, if the sample size is large, the shape of the distribution of sample means will be approximately normal.
Yeah, that's that law, right?
Yep.
The
Questions.
large normal.
Yeah, that's right. Okay. 9. Let X be a random variable population of 10, standard deviation 6, sample size 36. So we're just looking for the mean.
Oh, the mean, and that's always stays the same, right? So it's just 10.
Mm-hmm.
Or
Wait, are you saying that question 9 is 10?
yeah,
Yeah.
because unlike these ones, it's always stays the same.
Okay. So question 9 is 10. What is the standard deviation of the distribution of sample means?
It's a 10. Or wait, no, 6 divided by the square root of 36. Is that just 1?
So
Yeah.
you're saying 6 divided by 6.
Yeah, so it's 1.
1.
Yeah, okay.
You bought ice cream? Okay, so question 10 is 1, right?
Regardless of the distribution of the population. Yeah, sorry, it's 1.
Hey, I'm going to close this door. Sorry.
Sample size is large. What would be the shape of the distribution?
Wait,
Regardless of the
regardless of the-
distribution. Oh, you know how in the reading it said if it's 30 or more, then it's gonna be normal.
oh,
Is this the same kind of as the
30
earlier
more?
rule?
It's like they just said it was a rule of thumb. It wasn't an actual rule. It's just for this class.
Okay.
Oh, so it would be
Yeah.
normal.
Normal. Yeah.
Cool.
What theorem would you justify your response
Oh.
to the last question?
That'd be the central
Yeah.
limit theorem, right?
The
The
or
central.
the same thing.
Yeah. I wrote in like the answer key, he had said that the central, if the sample size is large, then the sample mean will be approximately
That's
normal.
why I thought that it would be normal, just because of that central limit theorem. But
Okay.
I don't know. Like it says,
That was a
because
quick-
that's what we picked. It says that if the sample size is large, the shape of the distribution sample means will be approximately normal. You guys want to go through it again, make sure we got it, or are you guys good?
Yeah, let's just try it. We have 2 attempts.
Oh yeah, we
It's 100.
It's 100.
Woo!
I already checked it.
Oh, sweet.
Yeah.
You're like,
I don't know. I just always want to make sure that I got it. Okay, cool.
Nice.
cool.
Awesome.
Okay, so for lesson 4, we didn't get points for that. So I don't know, like, because I think anybody can post that, like this video. Just make sure that.
Did I upload it
What?
for, wait,
Lesson
so
4.
last week's group?
It was the lesson 4 one. We didn't get points for it, apparently,
Okay.
because nobody from our group posted it. So I asked her, I asked her if the group leader does that or if anybody, and she said anybody can post it.
Oh.
I don't
I
really
had just been uploading it because I thought I was supposed to, but I just forgot to.
That's what I thought too, but anyway. So I wanted to make sure that everybody knew, or Julie, I guess, you are the group leader. I don't.
Yeah, I can upload.
Okay.
Do I still need to go back and upload that one, or did she say what to do?
She just said like we didn't upload it, so I would assume we didn't get the points for that, but it shouldn't kill us. So.
Okay.
Did we post lesson 5?
I'm pretty sure I did.
Cool.
Okay, well, I'll email her about it and make sure.
Well, because if you did, yeah, then you can tell her, I guess, or ask her. I don't know.
Yeah.
But yeah, I don't know if that's your job, but yeah, I guess you can post it.
So lesson 4, group collaboration. And then
So are we still doing this time for Thursday?
I'm down.
I have to do it a little bit earlier. I got called into work that day.
Okay. What time?
Sorry.
I'm cool with that too.
I have to go in at like 7:30.
Okay. So
It has to be sometime before then.
7?
okay, I posted. Sorry. Kind I posted last week's. Last one was I'll post.
All right, it's not a big deal. I don't know. I just wanted you guys like
Yeah,
a notification or anything.
post it right after.
Okay. So 7
Cool.
Tuesday or what time?
Tuesday.
Should we do earlier than
Sounds
7?
good.
Do whenever.
How far away is work for you, Austin?
Oh, it's just right there.
Okay.
Takes me like 5 minutes, so not too bad.
Okay.
That'll work.
Awesome.
All right.
Cool, guys.
Good teamwork.
Okay.
Thanks, Julie.
All right. Thanks, Julie.
Yeah.
Yep. Thank you. See ya.
Okay.
Bye, guys.
Bye.